I covered NanoRacks' Outpost proposal earlier this week and briefly mentioned that the concept isn't new. In this video, I'm going to cover in more detail the topic of converting fuel tanks into space stations. This concept was proposed by NASA's first administrator, Wernher Von Braun. He called it wet workshops. In a nutshell, the wet workshop concept involves launching a rocket up a stage filled with fuel. That's what wet means. Depleting the propellant in orbit, venting a residual propellant, and converting the now empty tanks into a habitable space station. In fact, Von Braun published the wet workshop idea in 1952 in a book he called The Mars Project. As an aside, the leader of the Mars settlement in Von Braun's book was called Elon. Von Braun considered converting upper stages into space stations as the cheapest path to permanent orbital presence. Now, let's look at Skylab, which was originally planned to be the first example of a wet workshop before it was later changed due to budget and risk reasons. Skylab wet workshop history. In the late 1960s and early 1970s, a plan was made to repurpose a spent Saturn upper stage as an orbital space station. It would be launched with fuel, that is wet. The fuel would be depleted with any residual fuel vented, and then the empty tank would be outfitted for human habitation. The plan was for a crew of 3 to 6 to stay on board for missions lasting 28 to 56 days. The outfitted tank would have internal grid floors, solar arrays, and a multiple docking adapter for resupply. NASA estimated the cost to be between $1.2 to $1.5 billion versus $3 billion for a dedicated station. The savings were due to using surplus Apollo hardware. Well, that was the plan. But as NASA worked on the idea, a number of challenges surfaced. Technical challenges. First, it became clear extensive number of spacewalks would be required to outfit the structure to make it habitable. Internal floors would need to be added, wiring and life support equipment installed. NASA considered this high risk, especially with a recently vented area with possible contamination present. Propellant venting issues were another challenge. Failure to completely eliminate all residual fuel risked explosive reactions. Another issue was ice formation clogging up systems or pipes. The upper stage lacked sufficient delta V, only 100 meters per second margin, to reach a stable orbit without assistance from the Apollo command module. In the end, NASA pivoted to a safer version for Skylab, a dry concept, where the upper stage would be outfitted before being launched into orbit. This allowed for full testing on the ground and with no fuel contamination risks. Skylab. The Skylab module, a converted upper stage, was launched in 1973 on the final launch of a Saturn V rocket. It was fully pressurized and equipped on the ground, weighing 91 tons when launched. 3 manned missions to Skylab launched between 1973 and 1974. The first mission was for 28 days, then 59 days, and the final mission was for 84 days. A total of 10 spacewalks lasting for 42 hours and a total crew time of 171 days. Without any more missions, Skylab's orbit slowly decayed and it entered the Earth's atmosphere in an uncontrolled breakup over Western Australia in July 1979. Skylab wet workshop legacy. Various later studies examined converting Space Shuttle external tanks into space stations. These images are from the Space Studies Institute study in 1985. The study found many advantages to converting what is essentially orbital waste into a valuable asset. While the study looked at the shuttle external tank, the analysis is valid for today's large first or second stage rockets. One key advantage is that these large tanks are already in orbit, or in the case of shuttle external tank, has 98% of the energy needed for orbital insertion. Upper stages contain large amounts of high-grade aerospace aluminium, or in the case of Starship, stainless steel. NASA studies suggest over 1,000 spent upper stages in orbit. Assuming an average of 5 tons per stage, that's 5,000 tons of material, much of it in low Earth orbit. This material can be cut, melted, welded, and reassembled into new structures, offering a ready-made supply of construction materials that are already in orbit. Massive habitable volumes are available if large tanks are converted into habitats. These structures are pressure vessels, so can easily be pressurized to one Earth atmosphere. Instead of outfitting for habitation, they could be converted into propellant depots or water storage, or other resources or consumables as needed. They could be used as hangars for repairing or upgrading space assets. Using tethers, they could be spun up to create spin gravity. They could be used for on-orbit manufacturing or for agriculture or hydroponics. There are challenges though. One is orbital stability and debris risk. Without thrusters attached, the lifespan is likely only months or less. Venting and ice buildup is a big risk factor that needs to be addressed. Insulating needs to be added for thermal management. Overall though, the advantages outnumber the challenges. ESA's wet workshop proposal for Ariane 5 upper stage. NASA isn't the only space agency to consider wet workshop proposals. ESA, the European Space Agency, considered repurposing their Ariane 5 upper stage into a modular space station habitat in low Earth orbit. This was to give Europe alternatives to US-centric commercial stations. The idea was to save money by using existing launch hardware rather than building something new. While this idea did not advance into flight hardware, it shows that the idea of repurposing spent upper stages is intriguing to various space agencies and companies. SpaceX's Starship first stage, booster. The first stage of SpaceX's Starship is huge and would make a large habitable platform if conversion was possible. Unfortunately, this isn't possible as the first stage cannot reach orbit in its current version or any future planned version. Even without an upper stage and fully fueled, its Delta-V tops out far below what is needed for a stable low Earth orbit. The booster is engineered solely for the purpose of lifting the Starship vehicle to orbit, and nothing else. SpaceX's Starship vehicle, second stage. The Starship vehicle can easily reach a stable low Earth orbit, making it suitable for conversion into a space station, even without repurposing the tanks. But if the tanks were vented, sealed and outfitted, then the Starship vehicle could be converted into a huge space station, with an internal volume twice that of the International Space Station. After reaching orbit, it's likely a Starship would have around 50 to 150 tons of methalox remaining. Perhaps this could be transferred to a Starship tanker that SpaceX is building. Tankers are required for SpaceX's human landing system. Any lingering methane could be expelled using thrusters or dedicated vents. The common bulkheads are pressure rated for 6 times Earth's atmosphere. We know stainless steel can be welded in space because NanoRacks Outpost Mars demo demonstrated this in 2022. Sealing and pressurizing the methane and oxygen tanks would provide an additional 1,500 cubic meters of internal volume. The fuel tanks would need to be built with internal decks with drainage holes, allowing fuel to move around inside the tanks. The added benefit is that these decks would act as baffles to minimize fuel slosh, which can be disastrous as shown by early Starship test launches. There's no official plan by Starship to use the wet workshop concept to extend the habitable volume of Starship, which is already large. However, SpaceX did apply to NASA's call for commercial space stations, but did not receive funding. They may apply for Phase 2 funding though. Now, let's look at an even better idea. Lunar Starship and the wet workshop idea. Starship will be going to the moon as they've been awarded a human landing system contract by NASA. Their first mission is likely Artemis 3. Starship is cheap enough that it can be used in expendable or single-use mode. After landing on the moon, the Starship propellant tanks would be vented to remove any residual fuel, or alternatively, pumped into storage containers since these propellants are valuable resources. The Starship tanks would already have internal decking in the tanks, with drainage holes and a central hole where a ladder could be fitted to access the lower decks. Early stage lunar habitat, Starship on the surface. The simplest way is to leave the Starship on the surface and outfit as described, using the Starship crane system to access the lunar surface. Later stage lunar habitat, partial burial. Later on, after regolith moving equipment is available on the moon, an area large enough and sufficiently deep to hold the Starship vehicle can be excavated. This can be done using a boom crane, maneuvering the vehicle into an excavated area so that the cargo door aligns with the surface. The lower decks would be underground and would make ideal living and sleeping quarters due to the extra protection of the regolith protecting against cosmic radiation, solar flares and micrometeoroid impacts. In addition, the temperature below the surface is a constant -20°C, regardless of whether it's the lunar day or night, simplifying environmental control. The above-ground decks can be used for work, science labs, and other activities. Regolith berms can be added around the exposed Starship vehicle, being careful not to cover up the cargo doors, solar panels, windows, or communications equipment. It's been suggested that the Starship vehicle should be lowered into a horizontal position, but the vehicle is not designed to withstand stresses in that orientation, requiring extensive structural support. I prefer the vertical position, ideally half buried, to give easy access to the surface with added protection for the living quarters in the below-ground lower decks. Other lunar base concepts, such as ESA's Moon Village, have multiple-story habitation modules, so there is no reason not to use Starship in its vertical orientation. Clusters of landed Starships could be linked together using inflatable tunnels, perhaps using Sierra Space's Life modules. This is a simple and relatively cheap way of building out a lunar base using vehicles that are already under construction and testing. Simple additions to the internal structures of the lunar Starship fuel tanks are needed to unlock a huge increase in habitable volume. The pressurized area above the tanks could hold all the outfitting equipment, pressurized gases, and welding equipment needed to convert the tanks, making the conversion process relatively straightforward. A lunar Starship with fuel tanks configured to include decks offers a pragmatic, scalable solution to building out a lunar base. It makes use of existing hardware under construction and requires only minor changes to Starship's internal tanks. Once landed, the Starship's mass and volume allows for all the outfitting equipment and tools to be deployed at the same time, making conversion possible in only a matter of days, depending on the length of time needed for removal and storage of residual propellants. Final thoughts. What do you think of the idea of repurposing upper stages as habitation modules? Robert Thompson, a NASA engineer in the 1960s, said when he heard about wet workshops, "Was just about the dumbest idea I've ever heard. And I've heard a lot of dumb ideas," unquote. Do you agree with him? Or do you think 60 years later, we have the technology to successfully repurpose upper stages into essentially free habitation modules in orbit, deep space, or the surface of the moon? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Space News Live is on Saturday evening or Sunday morning, depending where you watch from. The live stream is a great way for you to share your thoughts and opinions on the videos I posted this week, or on any space topic in general. I highlight the most thought-provoking comments on videos I've received, along with previews of upcoming content. If you got the time, please tune in and say hi. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.